Hello, everyone. So, my talk is not, can you hear me well? Not directly about Apache Sling, but about one of its friends, I would say, Apache OpenWhisk, which is still incubating, and but hopefully gets promoted soon. And I think we have a mentor here in the audience, so maybe you can help with that. My talk is about asset processing. Hands up if any of you have worked with extended DAM workflows in AEM. OK, that's a few. Did anyone look at things like workflow offloading or worked with the bulk ingestion that we offer with Adobe Managed Services? OK, a few. So you probably will know what I'm talking about. For the rest, I'll explain the background. So a little bit about me. I'm Alexander Klimetschek. I work for Adobe as a principal scientist and as part of the AEM Assets team as like an engineer and architect. I don't know if you remember me. I've actually been to the first two adaptTo conferences and gave talks, but I haven't been in the last 6 years, I believe. And I can see that the conference definitely grew since then. I think back then it was 30, 40 people maybe. Yeah, so let's get started. So let me first talk a little bit about how AEM asset processing looks today. That picture should give a little bit of an indication. So, but what we're dealing with? We're dealing with a digital asset explosion that you know because everybody has a smartphone, which is a camera, and so digital photos are produced at an ever-growing rate. And our customers have the same for their marketing, for their websites, and so on. It's more and more assets. So they want to store more of them. They get larger. These photos from modern DSLRs are pretty large. We see, so there's many numbers here, but one interesting one is that we see like the average asset size coming into AEM for larger customers is going beyond 100 megabyte. So if you think about like my JPEG is 5 megabytes, that's a thing of the past. So with that in mind, this is how our current ingestion and processing looks like. You got your AEM deployment, so this shows an AEM assets or an AEM authoring instance. So not talking about publish here. And so you might have a load balancer or a dispatcher in front of it, or maybe not. And that's deployed somewhere, possibly in the cloud and AWS or so. And nowadays, we often have S3 or Azure blob storage as the store for the binary in the backend. And so when the binaries are getting uploaded or downloaded, they go through all these instances. They go through the dispatcher, they go through the AEM, and then in the backend, they're synced back up to S3, for example. And there is a couple, with that situation and more assets coming in, there's a couple constraints. So the first one is the bandwidth available for binary streaming is defined by whatever the smallest of these instances is, and then you usually get a certain network bandwidth with your VM instance size and cloud providers. And since we're kind of sharing the same network connection on the AEM side for the traffic and the upload back to S3, you basically have that bandwidth. So if you want to have more bandwidth, you've got to pay for super large, expensive instance that you might not need otherwise. The second constraint is obviously, in most cases, it's a single instance that does all of the processing, and so you're limited to whatever I/O and CPU resources are available in there. So there's not a lot of doesn't give you a lot of headroom for scaling. And the third constraint, which is more of a software development constraint, is that since it's everything in the JVM and Java, you have to, whatever you want to do with an asset, be it image processing, video processing, and so on, has to be a Java library, which is often hard to find for more obscure or special cases. Or you have to install it next to AEM and run on the same instance. Then, we just saw a talk about memory management that has to then share memory with the AEM instance, and things get limited. So remember these three constraints. I'm going to talk about them. So also, you might have seen our Dambach Flows who grew in complexity. If you've been there, workflow models, launchers, I guess you know what I mean. Another thing, kind of a problem or challenge, is that if you have Adobe native file formats like Photoshop, and as soon as they're a little bit more complex, you upload into AEM, and then you get a blank preview, because we're not fully supporting our own file format. So that's definitely a bad user experience. And I mean, we could get away with it, right? When we were not Adobe, but after we got acquired, the longer we're there, it's like, you got to solve this, guys. And if you know, maybe since I think a year or a little bit longer, at least in managed services, there's a S3-based bulk ingestion available that does a little bit of scaling using multiple AEM author instances that are used for processing. But it's per customer, and it's really for typical initial ingestion when you do a new project and you build a new site. It's not fully integrated into the regular Assets UI or desktop app. But it helps a little bit. So now I'm going to tell you what we are planning to do. And it's a little bit of a revolution, I would say, in that area. So I mentioned these three constraints, and so they're kind of three pillars that we're trying to tackle them. So the first one is we're going to change the binary access to go directly to whatever the cloud storage is, S3 or Azure, Blob Store, the ones we offer today. And that allows us to reduce that bottleneck and reduce I/O limits within AEM by taking that binary streaming completely out of the picture. And then we can use whatever infrastructure they provide, which scales much better and gives us more options, like using CDN or transfer acceleration. And for the second constraint, which was about processing limitations on the JVM, we are building and will provide an asset compute service, that's what we call it, that is a multi-tenant cloud service to do the processing. And it will solve all of these things. It will be scalable. It will support Photoshop and other Adobe file formats in a much better way. And also, it's going to be setup free, right? So you no longer have to do customizations on AEM just for certain file formats. And if we have new file format support, it will be immediately available to customers. And the third part, and that's when I a little bit focus today, well, not focus, but in the demo at the end, is how we make that service easy to extend. Because we know that asset processing needs customizations. And so we built a service in a way that it's easy to extend, and we did that by using serverless technology, using Apache OpenWhisk. So I'm going to have a demo at the end about this. So here's a little bit of what does the architecture look like for these three things. So again, we have like a client, an AEM Assets author instance. The client could be a browser where user uploads an asset, or a desktop app, or another tool. And so rather than going through AEM for the binary upload, we talk to AEM, or the client talks to AEM for the upload coordination, ensuring access control is exactly the same as before. But then when it comes to actually uploading or downloading the binary, it goes directly to the cloud storage, S3 or Azure. And the Oak data store connection in the backend also, again, kind of is reduced for the most part to coordination, but not necessarily streaming the binaries. So it means that essentially we want to make, at least for AEM Assets, these AEM instances binary-less, right? So the binaries never end up on the AEM instance. And so you can imagine that is, there's been solutions or projects, I think, where that was done when it comes to your really large video files, right, where it's obvious that doesn't make sense to put them into the JCR. And so we're extending this and making this kind of a core feature of the product. And then for the processing, we go to the Asset Compute Service, which AEM will trigger and tell it, here, please generate these renditions, do this and that for me. And again, the Asset Compute Service will directly access the binaries as well, read them, and push back any renditions it generates to the cloud storage as well. And number three, the extensibility comes in the form of custom workers that kind of can be run as part of that service. So benefits for this are some, I mean, I mentioned some, but I'm going to show some more. So for the first one, when we enable CDN, when we enable direct binary access, we can use features of the cloud storage. For example, both Amazon and Azure offer a CDN for their binary storage, which is just a matter of a configuration, and everything else is handled automatically, including private buckets. And only Amazon also provides transfer acceleration for uploading, which dramatically improves the band or the speed across geographies, because you get to, well, you pay extra, but you get to use their whatever dark fiber they have across the world between their data centers. And in between the West Coast and Europe, it can be up to 15 times faster than going through the public internet. And so for situations where customers have offices across the world and want to run AEM instance, that definitely improves their experience. And the second, or for the second point, for the cloud processing, we get scalability. So we have one multi-tenant service, and we can run processing in parallel across all customers, across renditions, and have kind of efficiency of a shared environment, right? That also kind of negates the different load patterns. And yeah, and the extensibility, it's just part of the service like any other. So whatever you write as an extension gets all these benefits, the scalability, and so on as well. So you might be wondering, okay, he talks about the future. What does he mean by that? So actually, I'm happy to announce that we are planning to release this with our next release, 6.5 in April. And the combination of direct binary access and the service. The extensibility will come a little bit later. In the beginning, it will be standard out-of-the-box renditions and configuration of extra renditions, but custom steps we'll roll out a little bit later. And the requirements for that will be managed services only. And of course, the whole design requires to have an S3 or Azure data store. Now, having talked about the general problem and idea, let's talk a little bit about the technical details about how that service works. So, and I mentioned that is based on serverless and Apache OpenWhisk. So I want to, for those who might not have experience with that, that's a good question. Who in the audience has used any serverless like AWS Lambda, Azure Functions? Okay. Who of you have used Apache OpenWhisk or Adobe I Runtime? Okay, a few. So a lot of Adobe folks, I think. So I want to give a quick introduction so you understand why we chose that. So this is a slide that everybody includes in their serverless presentation, so I do too. But I think it explains nicely what serverless is. So it's kind of the evolution of how we do computing, server-based computing, and starting with physical machines directly installed in your data center, then virtual machines were abstracted and allowed the cloud to become a thing and automate deployment. And then people figured out, okay, that's big. VMs are big and not so efficient, and containers came along and were much smaller and allowed more efficiency and the improvement of the whole deployment. And it's also much faster to start, so you can do things you couldn't do with VMs. And then serverless is really, right? I mean, it's not really serverless. You still have servers under the hood. But the idea is that you deploy functions, which is just application code. And you don't have to worry about any server infrastructure. You don't have to worry about starting and stopping your JVM. You don't have to worry about thread management and so on. And so that's why it's called serverless, because it's you focus completely on the application logic. And it's small, live in seconds, and also gone in seconds. It's allows much more on-demand processing. So the serverless platform we are looking at is Apache OpenWhisk, which is an open source one that was started internally by ABM just a few years ago, and then I think they completed it in 1.5 years, and very quickly made it open source, brought it to Apache, and it's in incubation since then. And Adobe jumped on and chose it for its serverless needs, as well as Red Hat. So Adobe, IBM, Red Hat are the big three supporting that project. And OpenWhisk supports all kinds of languages that you can write your functions in. Definitely Node.js is the most popular one, but you can also do it in Java, like a little jar. Whatever, each language has kind of a different entry point, but it's the concept is the same. It definitely lends itself more to scripting languages, but it's not restricted to that. So how does it work? So this is a simple Apache OpenWhisk example. So this is a very simple minimal piece of code. It's in this example in Node.js. So you write a simple JavaScript. You got a main function that's your entry point by default. It can get parameters. In this example, it doesn't even get them. And it just returns a JSON object, which is the result of the action. And in this case, just returns hello world. And now you have your OpenWhisk platform somewhere, and you want to deploy it. So what do? You have there's a REST interface, but you get a command line application, WSK, Whisk, that you can use to create an action. And so that's your deployment. You specify a name for the action. And that's a thing in less than a second. And then you can execute it. And again, same API, but you use for development you use the command line app as well, and you invoke your action, and then you get back a result, and that returns your hello world, and then plus additional metadata. And that's it, right? So that is a complete development, deployment to production, and invocation. You don't have to, there's no server you had to deploy first, there's nothing you had to start, and so on. And this thing is automatically scalable, so if you invoke this 100,000 times in parallel, assuming that installation is large enough of a cluster, it will support that. So Adobe chose OpenWhisk and offers this, it's still in beta, but it's going to be released soon, and calls it Adobe I/O Runtime. And it's meant to, with all Adobe's cloud platform efforts, as a way to extend the platform and integrate, build integrations with solutions. So you might wonder, why did Adobe go with OpenWhisk rather than relying on what AWS or Azure provide? And so one part is definitely to be a little bit in control, because for the work we do with the platform, there's definitely the need. Because it's an open source project, right, and Adobe is part of the committers, we can definitely help build this, also including the needs we might see. But from a feature perspective, one interesting point is that OpenWhisk, unlike most, supports containers, and that means you can have more than just an action. And so I don't know if you've seen that XKCD comic. It's a couple of weeks old. I think it hits the nail, especially in the combination of containers and serverless, is that rather than having to integrate things in a certain language runtime, which are naturally in that language, and you spend a lot of effort, you can glue things together very efficiently with containers, and serverless makes it very easy. So that allows Adobe, because of the custom tooling we can put on these containers, to have our proprietary rendering tools and SDKs and libraries for the Adobe platform and Adobe tools, Adobe products, already part of it. So then when you write an action, it's super simple, because all these things you need to do to work with Adobe stuff is already there. So the second question you might have is, okay, why do we choose serverless for asset processing? Well, there's a couple. One is, asset processing, as we do it, is asynchronous by nature. And if you start with serverless, asynchronous is definitely where it makes the most sense immediately, right? And then a lot of these integration use cases with serverless are based on eventing, where some event triggers a function to do something else. And so that's a good match. You can do serverless for synchronous stuff as well, but that's really a new area of software development that's still evolving, and the optimal designs for that are still evolving. There's a little bit more work. But for asynchronous, it's a match. It is highly scalable, and that's what we need. You get sandboxing for free, right? So if people upload a bad file and it crashes or hangs forever, or there's a virus in it, the platform has to handle that, right? Because it's executing custom code and needs to protect that code from doing anything bad to the platform. It's extensible by nature, because it is built extensible, so we can, for the needs of enterprise workflows, we can offer that. And we can do cool stuff like, because serverless means dynamic scheduling, right? So because the serverless platform at invocation time will make the decision where to run something on an existing container or having the need to start a new one. And we can make the decision to run this close to, for example, the S3 bucket if there's a cluster in that data center available. So that gives the workers the best possible speed access to the data. And last but not least, it's, I think, super cool to work with. A lot of the responsibilities are handled by the platform, and you can focus on your application code. So let's talk a little bit about the service that we built. How does it look like, or what do we do? So in the beginning, we want to support this for AEM. So we will support whatever AEM supports today. Plus, we start with better Photoshop support than before. This is kind of apart from the performance benefits and scalability, that's kind of the feature benefit, the initial goodie. And then we're going to support for the source files. We're going to support, that's what AEM does, raster images, raw files, and so on. Video, still a little question mark there for the first release. And then renditions, thumbnails, web renditions, metadata, and text. So metadata and text are kind of new things because we move these binaries out of AEM. We have to handle that externally as well, and not on AEM or in Oak, for example. So I think I got to hurry up a little bit. But the API is pretty simple. It's essentially one endpoint where you post the JSON to tell it to process. And simplified JSON might look like this. So there's kind of three elements I highlight here. So one is the source, which is the reference to the binary. And there will typically be pre-signed URLs pointing to S3 or Azure data store, blob store. We can extend that to support other forms of storage, but we start with pre-signed. And then you basically tell it an array of renditions you want to generate. And hands up, anybody who has used Scene 7 image serving? Oh, yeah, a few. Great. So you might recognize some of these fields there, because at least for the image operation parts, we let us inspired from that format. So we have the FMT for format, tell what the resulting format should be. Hey is short for height, to specify the pixels the height in pixels, and so on. A couple of these others we want to use. So just we start with something that has some familiarity, and we're going to extend it for the other file formats that are new that the Scene 7 didn't have for new kinds of operations we might have. And then for each rendition, you specify the target, which will be another pre-signed URL, but this time for writing back the rendition. And then this thing is asynchronous, so you immediately get back a drop identifier. And when things are done, you'll be notified through an event system, or when there's an error, or maybe for long-running operations, a progress update. So you could show that to the user in AEM, for example. And I mentioned we're going to allow extensibility. So if you look at the JSON for that, right? So it's the same JSON, but this time we have one rendition that's supposed to be a custom worker. So you can specify the worker explicitly there, and the name of that will be pointing to your namespace in runtime. So namespace is the account concept. So there might be your or the customers or whatever namespace, and you reference the action in that namespace so that the service can invoke that. And there will be authorization needed there as well, but it's not shown here. And it's kind of the full power of serverless, because to the service itself, whether it's a standard worker or a custom worker, it doesn't really make a difference. So this is the service architecture. At the top, you see a client like AEM that makes a request to process a job to the service. So the service is kind of the blue dotted box. That's all the parts of the service. On the left-hand side, there's the binary storage, which I showed before, where we reference them, and then each component will access them when needed. And then we have a couple of workers here, and each worker are these yellow, red, blue boxes. And if you look at the standard worker on the left, I highlighted these three components because they're the most important ones if you look at it. So the yellow part is the worker. That's the action code in terms of OpenWhisk, an action that you write, and that does the particular thing you need to do. Then the red part is the common library that is part of the service, kind of library or SDK, what you want to call it, that allows, or that takes care of the boring standard stuff like downloading the binaries, uploading them, error handling, eventing, and so on. So that keeps the worker code you have to write super simple. And then underneath, there might be a container, that's the blue part, that includes maybe custom rendering tools like Photoshop library in our case, or ImageMagick, or FFmpeg, and so on. But you can also at the same time have workers that might not do local processing, like that do a composition, that call another service to get some information, make some decisions, some completely custom, maybe personalization workflows where you create personalized images based on data from the customer or so. And an important thing, and I'm going to show that in a second, is we have a good and easy integration with Adobe Sensei services there. But because serverless, you can do anything. You can call any service, Adobe's or customer or other third-party systems. Yeah, and then at the top you see kind of the events going back. So it'll be using Adobe I/O events as a public-facing event system where you get back the events. And we plan to, in the beginning, we offer this with AEM, but we plan to make this service available for direct use, not necessarily coupled with AEM. So let's go into the demo, and I want to show you how you can write a custom worker. First of all, the service, and then how writing a custom worker would do. And the custom worker is supposed to integrate some Sensei magic. So I did pre-record a video because there was a little bit slow the network, and I knew the network. But so here, that's a little developer tool to run the service, and so you got to see the JSON there. And so I'm having a PDF from my talk actually, and running that through, and I'm requesting a PNG thumbnail rendition that's 600 by 600, and then full text extraction. So you see that there was the slow internet here that's slowly loading. And just open that full screen, and you see, okay, well, it extracted the cover page. That's nice. And then for the full text, it's pretty simple. You just ask for the text. There's no extra parameters. And then you get back the full text as a plain text, and you see that's the text from my slides. Yay. So, and then let's look at another file type, a photo. We have this photo. You see that was the kind of a preview of the original. And we run the same request for it. And we see the text is empty because it's an image, and it actually doesn't have any text. So no surprise there. And then we got a PNG rendition there as well. So yeah, pretty straightforward. So what I'm going to show now is how we want to use a Sensei service, which is a title prediction, which gives automatically gives a caption for an image. And I want to add that to the image itself. So kind of a composition of a Sensei service and some image processing. So I'm switching to the console. I'm creating a new directory here. And so we have a command line client. So I'm resizing this because it was a little bit too big. So we got our little NUI is the name, the code name of the project. So we call it the command line client there as well. And it's for developers and has all things around deployment, packaging, making it easier. And so we got to have a NUI init there to create a new project based on a template. So we want to create a Sensei-based one. So we create a, say, NUI init Sensei. It also ran npm install there just to have our dependencies readily available. So open this in Visual Studio Code, which seems to be the popular IDE nowadays. And so we have a worker.js and a package.json. This is actually just the two files. The rest is the npm stuff. And so the worker.js has some bunch of common stuff at the top, some imports. But this is the interesting part. This is the main function, if you remember the simple hello world before. And that's the main entry point. But here we got a little bit of a NUI's library there, which iterates over multiple renditions and does all the downloading in the background. So you get back the source, which is the file name, the source file locally. And rendition is the file name you want to generate, the rendition. And before that, it will download. And once this is done, it will automatically upload. So in this piece of code, we only have to do our processing. So here it's calling a Sensei service, and so that's the first thing you want to do. You're going to ask Sensei for a title prediction. So the name of that feature is called title prediction. So it passes the source file reference to Sensei that calls the Sensei service in the background. And then we get back a JSON, a more complex JSON with multiple candidates and different confidence level. And for this example, just picking the first one, so that's reading that from the JSON. So trust me, that does the right thing. And then in the third step, we want to call a locally available image magic to add that caption as a footer to the image. So so this is all the promise handling you got there. The promises are really viral when you do too much in JavaScript. So we got the caption there, and then we call the image magic command. And I copy-pasted in here because it's a little bit longer, but it's standard command found directly taken from the website to do that use case because it seems to be common. You pass the caption, you pass the source file, and the rendition. So that's very simple if you can use the command line app. And then a couple other options about the font size and background color. So that's it. So I'm done with my worker code. I'm switching to the package.json, where we also specify things important for the deployment. So we have some custom fields there. So the name of the project, image caption, will be the action/worker name. And then we can add a little description that will be, it's kind of an annotation. And some of the other stuff was, part of the template, and I have to worry about that. So back to the shell. And so this command lists all the actions in my namespace right now. So we got a couple of that, part of the our little NUI service there. And like this is a development namespace. And so I run NUI deploy to deploy that package.json on the local project. So it automatically uses Webpack, different use case for Webpack, but very useful to make your actions smaller. And then it deployed it, and it shows you what it deployed. And it deployed it to Runtime Adobe O, which is the Adobe I runtime service that is OpenWhisk, essentially. And now I list the actions again, and you see at the top, the image caption has been added. And yeah, so we can go back to our developer tool here. And now request a new rendition using our new worker. So the name was image caption, so we specify that explicitly. And then we can also specify the file name that is used to tell ImageMagick that it should create a JPEG, so we need that here. But you could have your own options and or own parameters here. So we run this, so it's going to run all these renditions again, and our new one. And so takes a bit, and then images are loading. I could sped up the video there a little bit. And so that's the result. So Sensei, pretty impressive. Group of friends sitting on a bench in the park. That's exactly what it looks like. Wouldn't have named it any better. It's completely automatic. And so let's take another example. So that was slowly loading, but it's a picture of an elephant. Yeah, I had to skip there because it didn't finish loading, but then that was just the original. And so we run this again. So the caption takes a little bit longer, because multiple services involved. And we're loading it, and it says, elephant in Kenya. I don't know why it thinks it's Kenya. Maybe it recognizes that particular tree. But I don't know. That's, Singularity is coming soon. Well, yeah, so that's it. So we got this thing developed, deployed, and it's scalable automatically. It'll have error handling and so on because that comes part of the library. So that's, maybe if you're good, a 1 to 2 hour job for a little integration like that. So yeah, that was my demo. So just highlighting again what was involved. That was about the source code, the actual lines of code we had to write, to use a term from Bertrand. And I was able to reuse ImageMagick. I could just do a little bit of a Googling to find the right command, try it out, and then integrate it here. I didn't have to load any libraries and get them to work. And the package JSON just for the description of the package and the deployment unit, if you will. And then we got our result. So yeah, these are some of the resources. Since we are not public yet, we don't have any public documentation yet, so please stay tuned for AEM 6.5. But in the meantime, you can look at Apache OpenWhisk. It's very active, very cool. And our I/O runtime documentation, and then also follow the Adobe I/O Twitter, and in our Adobe brand new Adobe tech blog, which Adobe tries to talk, explain more about what we do, what the cool stuff is we're doing technically across the company. And you'll find a lot of I/O and runtime related things there as well. And yeah, so I want to thank you and kind of remember these 3 things that we want to do to kind of tackle these limitations we have: direct access to cloud binaries, asset compute service, and we want to make that easy to extend for you guys. And yeah, with that, I might have a little bit of time for questions. Thank you.
Any questions?
So this is based on serverless, right? And I was wondering how much does it usually takes to generate renditions for an asset when you upload? Does it fit into the serverless constraints, or how do you handle, for example, large videos or things like that?
Yeah, so that's it's a good question, and that's another reason why Adobe has its own serverless platform, because we can tweak these limitations to what we need for use cases like this. So if you look at typical serverless, or I think AWS Lambda started with a 1 second limit of execution time. With OpenWhisk, the default is a minute. but we can increase it for what we need, and the runtime team is offering that flexibility. So and it's execution time, available memory, available local disk space, potentially control over CPU or GPUs that might be needed. And the great thing about serverless is kind of you can schedule this dynamically, right? So as part of your when you execute, you could have that annotation and asking for whatever you need, and then can choose the right one. So video processing would ask for more than maybe a thumbnail generator.
Okay, thanks.
Okay, San. You talked about that it's only available via Adobe Managed Service, and I understand that it's probably hard to replicate all these features when I'm deploying on-prem. But what about hosting my AEM myself on AWS? I think I can use all these services from AWS or Azure. I can access the compute servers. So can I replicate all that stuff with a little bit of engineering on my own?
Well, you probably can. I know you can. But I think that's a dedicated decision to kind of focus this on managed services, right? So that we can guarantee the best support, especially with these multi-cloud service integrations where we have more and more of them. The operations become, more complex or involve more of Adobe's services. So that's why kind of the focus there is on managed services deployments. Not satisfied?
Okay. So will there be code which is only deployed in Adobe Managed Services, or will be this direct access to cloud binaries already available as part of a regular 6.5, and I could use it on my own?
So a few things. Well, it will be an option, so we will still support the old model, but when it's going to be the combination of the two in the beginning, so you don't get to use direct cloud binary access directly. Maybe for custom stuff you do unrelated to assets itself. Actually, there's a little bit more detail on how that works. There's a lightning talk that Matt will give tomorrow about how the direct binary access works in Oak, some of the new APIs, because that's already available in the latest Oak trunk. But I think in terms of supporting that for assets as an application, we want to, at the beginning at least, limit that to a whole package that we can support well. I'm an engineer, so don't ask me these questions.
Any further questions? Okay. Thank you very much for your talk on stage there.